Hello everyone. Welcome to day 11 of 100 most asked network engineer interview question and answer series. Guys, this is day 11. Till now we have discussed 50 questions, 50 most important questions for network engineer interview. And today in this video we are going to discuss 5 more questions. But today's questions are based on STP protocol. STP stands for Spanning Tree Protocol. So guys, first question for the day is, what is STP? What is STP and why do we use it? Why do we use STP protocol? So many times interviewers are asking this question in network engineer, right? So you have to share your answer whenever interviewer will ask you to explain STP. So what is STP? STP stands for Spanning Tree Protocol. It is an open standard protocol, right? And it is a layer 2 protocol. If I talk about IEEE standard, so STP uses IEEE standard 802.1t, right? And by default, it is enabled on all Cisco switches, right? On all Cisco switches, STP is enabled. But what is STP? Guys, STP is a protocol which is used to avoid layer 2 loop, First of all, let me explain how a loop can create in topology. Suppose we have two switch 1 and switch 2, okay, and suppose here is some user are there, and here is some user, okay. So, and there is one link between switch 1 and switch 2. So guys, whenever this link will goes down, right, my communication will be stopped from this network to this network, right? So there is no redundancy. So for backup, for redundancy, I will connect one more cable over here, right? So if I will connect one more cable over here, then loop will create here, right? How loop can create in this network? So whenever this machine will generate a broadcast message, that broadcast message will receive by this switch. Now what switch will do? Switch will check destination MAC address. Destination MAC address is broadcast. That means switch will out this frame from all of its port except the port on which switch 1 received this frame. So switch will forward this frame from this interface, right, except this interface. Now when this switch number 2 will receive broadcast message on this interface, now switch 2 will again check destination MAC address. So destination MAC address is all up. Now again switch 2 will forward that broadcast message from this interface, right? So now switch 1 is receiving same frame, right? Same frame from switch number 2 that switch 1 has sent to switch number 2, right? So this is loop. Now this frame will forwarded by switch 1 to switch 2 and switch 2 to switch 1 and then switch 1 to switch 2, then again switch 2 to switch 1, right? So your frame will be moved like this here. So this is loop. So to avoid this loop, we are using STP protocol. So STP stands for Spanning Tree Protocol. It is an open standard protocol. It is a layer 2 protocol. By default, it is enabled on all Cisco switches, right? So in layer 2 network, you can see this line. In layer 2 network, whenever you will go for redundancy, a layer 2 loop can be created. So to avoid this loop, we are using STP protocol. Fine. STP protocol. How STP will avoid this loop? Actually, STP will block one link logically. STP will block one port logically on the loop, right? After that, STP is a network protocol that builds a loop-free logical topology for Ethernet network. Okay, so this is what is STP and why do we use it. Let me move on next question. That is question number 52. So this is question number 52. How STP works, right? Guys, this is also VVI question. Right? Many times I have faced this type of question in interview, right? And many of my students also acknowledge me that my interviewer is asking about STP protocol, how STP work, right? So this is very important question. Many time interview is asking this question in to network engineer, right? So understand how STP works. So first line is STP uses a spanning tree algorithm. STP protocol is using STA algorithm to create a topology database of network, right? Actually STP will create one logical network over physical network with the help of STA algorithm, right? A spanning tree algorithm. To prevent loop, a spanning tree algorithm placed some interfaces in forwarding state and other interfaces in blocking state. This is very important line, right? SPA placed some interfaces in forwarding state and other interfaces in blocking state, right? Out of, guys, on this point, right, I am here. Out of all the switches, one switch will elected as root bridge, right? So suppose in my network we have 4 switches, right? So out of these 4 switches, one switch will elected as root bridge. Root bridge means main switch, and all other switches will act as a non-root bridge switch. So suppose this is my root bridge switch. You will understand what is the election process of root bridge, right, in my theory video, right? So we have discussed these things in theory class in STP, right? How a switch will how in a topology root bridge switch will be elected, right? So actually they will check bridge ID. Lowest bridge ID will be preferred. Lowest bridge ID, the switch who have lowest bridge ID, that switch will become root bridge switch. So suppose this is my root bridge switch, right? So all other switch are non-root bridge switch, non-root bridge switch, non-root bridge switch. Okay, this is all other switches are non-root bridge switch. And guys, here you can see all the switches will send a hello message after every 2 seconds. All the switches at the first time only all the switches will send hello message, right? After that only root bridge switch will send hello message, and that hello message is known as BPDU, right? Bridge protocol data unit, right? So all switches are sending a hello message to their neighboring switch, and that hello message is known as BPDU. Okay, now see, non-root bridge switch will always listen for BPDU from root bridge. So suppose we have 2 switch, switch 1 and switch 2, suppose the MAC address of this switch is 0A, MAC address of this switch is 0B. So definitely now if I talk about bridge ID of this switch will lesser than the bridge ID of this switch. Actually bridge ID is also combination of 2 things, priority plus MAC address, right? So by default priority is same on both switch number 1 and switch number 2. If I talk about MAC address, so here is list MAC address, so definitely this switch will become root bridge switch and this switch will become non-root bridge switch. Okay, and suppose we have 2 link between switch 1 and switch 2. Now non-root bridge switch will never send BPDU, always listen for BPDU. At the first time switch number 2 will also send BPDU, right? Because now switch number 2 don't know who is BPDU, who is root bridge, right? So when switch number 2 will came to know that switch number 1 has lower MAC address, has best bridge ID, then switch number 2 will came to know that okay, switch number 1 is my root bridge, now I will only listen for BPDU. Okay, now if non-root bridge receive a BPDU from root bridge on more than one port, it will come to know that there is a loop. Now whenever this switch number 2 will receive a BPDU, right, a BPDU from root bridge on more than one port, that switch will come to know that there is loop. Now switch number 2 will receive same BPDU on how many ports? On 2 ports. Now switch number 2 will come to know that okay, there is one loop, loop. Now it will block ports except one port where switch will receive superior BPDU. Guys, superior BPDU means best BPDU with lowest cost, with lower cost. Okay, so this switch will block one interface, right? This switch number 2 will block one interface because switch number 2 is receiving superior BPDU at how many port? On 2 port, right? Same BPDU, same superior BPDU on 2 port. Then switch 2 will came to know that there is one loop. Now switch 2 will block one link, right? Except the link. Switch 2 will block all the link except one link, the link on which switch 2 will receive superior BPDU, right? So what is the meaning of superior BPDU? Superior BPDU means with best cost. If I talk about cost, so cost of this interface is 90 and this interface is 90. By default cost is 90. So cost is tie. Then switch number 2 will check sender port ID, sender port ID, or you can say designated port ID. So suppose the port ID of this interface is 0/0, over here is 0/1. So now here switch number 2 is receiving superior BPDU. So switch number 2 will block this link, right? This port. Now my logical topology is like this, right? But whenever this link will goes down, this link will automatically up, right? Because physically this link is up, but logically this link is block. Okay, so this is how STP works. You can explain to interviewer if interviewer ask you to explain how STP works. Okay, now guys, let me move on. Next question. Okay, so next question is, what is the spanning tree path cost? Guys, these are the predefined value, or you can say fixed value. The cost is a value. This cost value is inversely proportional to bandwidth, right? Cost is inversely proportional to bandwidth. Higher the bandwidth, lower the cost. Always keep in mind this point. Higher the bandwidth, lower the cost, right? So if I talk about cost of 10 Mbps link, so cost of 10 Mbps link will be 100. Cost of 100 Mbps link will be 19. Cost of 1 gigabit is 4. 10 gigabit is 2, right? So this is predefined value. You have to keep in mind. These 4 bandwidth and cost. Okay, this is predefined. But you need to understand the working of STP. Actually, what is the use of STP? So STP is a layer 2 protocol which is used to avoid layer 2 loop. How? So whenever non-root bridge switch will receive superior BPDU at more than one interface, then non-root bridge switch will came to know that there is loop. Now switch number 2 will block all interfaces, all the ports except the port on which non-root bridge switch will receive a superior BPDU, right? This is the point. Okay, now guys, let me move on. Next question number 54. How is the election of root bridge done, right? You can see this question, right? How root bridge election is done, right? So root bridge election of root bridge is based on bridge ID, right? This is based on bridge ID. This is also important question. Interviewer can ask you this question as well, right? So what is bridge ID, by the way? Bridge ID is combination of two things. First one is priority and second one is MAC address. But you can say, understand first of all this line, election of root bridge is based on bridge ID, right? Now definitely interviewer will ask you to explain bridge ID, right? So what is bridge ID? You can say bridge ID is a 8 bits value. How much? 8 byte value, right? 8 bytes value. It is a 8 bytes value, and it is a combination of two things. First one is priority and MAC address, right? MAC address. 2 bytes priority and 6 byte MAC address, right? As you know, MAC address, length of MAC address is 6 byte, right? And by default priority on all the switches is 32768 plus whatever MAC address of your switch is using, right? So here you can say the switch with lowest bridge ID will elected as root bridge ID with lowest bridge ID, right? Now bridge ID is 8 bytes value. Bridge ID is a combination of two things, bridge priority plus base MAC address. After that bridge priority is bridge priority equals 2 bytes and by default priority is 32768. Okay, so suppose we have two switch number 1 and switch number 2. Suppose the MAC address of switch number A is 0A and MAC address of switch number 2 is 0B. So by default priority is 32768. Here also 32768. Now switch 1 will calculate their bridge ID. What will be the bridge ID of switch 1? 32768 plus 0A. What will be the bridge ID of switch number 2? 32768 plus 0B. Now which one is lower? So this one is lower, right? This one is lower. So switch 1 will become root bridge switch, right? Now switch 2 will block one link, either this link or this link. Okay, so this is the root bridge election process, right? After that, let me move on last question, and this is a scenario based question, right? This is a scenario based question. Let me discuss it. In this scenario, if switch 1 is the root bridge switch, okay, which switch is switch 1? This switch. This one is root bridge switch. Let me change the color of my pen. This is my root bridge switch, okay, and all the ports of all the switches have the bandwidth of 100 Mbps, okay. So bandwidth of all link is 100 Mbps, so definitely cost will be 19 for all link, right, of all ports, okay. And suppose the MAC address of switch 1, switch 2 and switch 3 is 0A, 0B, 0C. Suppose the MAC address of this switch is 0A, MAC address of this switch is 0B, MAC address of this switch is 0C. So definitely switch 1 will become root bridge switch because it has lowest MAC address, because priority is same, right? Then which port will be blocked, right? Which port will be blocked? Guys, always remember one thing, right? All port of root bridge switch will become DP. DP means designated port, right? Designated port. Always keep in mind this point, like this. A port which transmits superior BPDU, that port is known as DP, designated port. Port which transmit superior BPDU, okay, that port will become designated port, right? A port which will receive superior BPDU, that port will become RP, right, root port. So here superior, this switch is sending superior BPDU, right, and this switch is receiving superior BPDU on this port. So this port will become your RP, and this switch is receiving superior BPDU on this port. So this port will become RP, right? Now this switch will relay that BPDU from here, right, and this switch will relay that BPDU from here, right? Whenever switch 2 will receive a BPDU from switch 1, so switch 1 is receiving superior BPDU on this interface, so definitely this interface will become RP, because a port where you are receiving superior BPDU, that port will become RP. Now who is sending superior BPDU, switch number 2 or switch number 3 on this link? On this link. So when switch number 2 is sending BPDU, right, and whenever switch number 3 is sending BPDU, both are sending same root bridge ID, that is 32768 plus 0A, right? Both are sending same root bridge ID. Then they will check bridge ID. Root bridge ID is tie, same. Then this switch will check bridge ID. So what is the bridge ID of this switch? Bridge ID of this switch is 32768 plus 0B. Bridge ID of this switch is 32768 plus 0C. Which one is lowest? This one, right? So this switch is transmitting superior BPDU from this port. So this port will become DP. Again, DP, the port who is sending superior BPDU, and this port will blocked. This port will blocked. Okay. So these are 5 more important questions for network engineer interview. Okay. So till now we have discussed 55 questions, and in next video we have discussed 5 more important questions. Okay. So that's all for today. Bye bye guys. If you like this video, please click on like button. If you haven't subscribed my channel, please subscribe this channel, PM Networking. Bye bye. That's all for today. Thanks for watching.